Hi guys, so in this video we are gonna go through the question permutation subsequences from Starters AD of Codechef. So let's get started with the question itself. So the question states that Shefina has an array A consisting of n positive integers, a permutation, then they have given a definition of a permutation that we already know, so I'm not going through that. Now Shefina asks Shift to find out the count of permutation subsequences in array A, and since this count can be really high, so we have to take the modulus with a prime number, or the most popular prime number, 10 to the power 9 plus 7. Also, as a reminder, subsequence, then they've given the definition of subsequence and all that stuff. Okay, so a permutation of length m in an array of length m, in which every element from 1 to m occurs exactly once, is called a subsequence. I hope everyone knows that. Now, this is what they've given. So they have given basic n, or the number of elements. Then they have provided us with the array itself. Now we have to make any like we have to make subsequences out of it, and we have to print the number of subsequences that we can make. So over here, let's say for this particular array, one is definitely definitely a valid permutation. So the subsequence needs to be a valid permutation. Now 1 2 is a valid permutation, but they're again writing 1 2. That is because there's a 2 over here and there's a 2 over here. So we can select any one of them, right? Then we have 1 2 3 or 1 3 2, then 1 2 3 4, 1 3 2 4. So yeah, you can select any of the elements, and if a particular element is occurring more than one time, so for example over here 2 was occurring more than one time, right? So both of those occurrences would be counted as different occurrences, and if you so basically two indices that are not equal, if you're using them, so those are counted as two different subsequences. So let me just explain that. So what I'm saying is that if you are having this kind of array, so let's say this was one, this was two, this was also two, right? So if you so this is the index zero, sorry, yeah, zero. This is one and this is two, right? Now if you're using 0 and 1, so you will be the indices 0 and 1, so you'll be getting 1 2. So these are the indices and these are the corresponding values. At 0 you have 1, and at 1 you have a 2, right? So from 0 1 you will be getting a 1 2. From 1 and 2, sorry, from 0 and 2 you will also be getting a 1 2, right? From 0 itself you will be getting a single 1. So over here, different subsequences actually mean that a subsequence which are different by the indices itself, right? So over here we can say that it will get us three subsequences. Let's check for a different example. So let's say it was 0 1, oh sorry, not 0 because it can start from 1 itself. 1 2 2 and 3, right? And the indices are 0 1 2 3. Now here, over here 0 is a valid subsequence, so is 0 1, right? 0 2 is also valid subsequence. 0 1 3 is also valid subsequence, and 0 2 3 is also valid subsequence. By valid subsequence I mean it's a subsequence and it's all also is a permutation, right? Okay, so this gives us 1, this gives us 1 2, this gives us 1 2, this gives us 1 2 3, and this gives us 1 2 3. Now how would I do it in practice? Is there a way I can do it in order of n complexity? Now I'm not worried about space complexity of being order of n or not, but yeah, can I do it in order of n time complexity or not? I can actually do it. So what I'll say is that let's the initial element for any subsequence has to be one. That's obvious because a permutation will always contain a one, right? So let me start from one itself, and let me say what's the frequency for this. So let's say the frequency of one is f. So to construct f itself, or to construct one itself, the number of ways of doing it is f itself. So I'll add f to my final answer. Now I'll keep a track of it. So this is the previous answer. Now I'm moving on to okay. So this was for I is equal to 1, and now or num is equal to 1. So let's call it n is equal to 1. Now I'm checking for n is equal to 2, and this when I'll go for n is equal to 2, this will become my previous. So previously I was having a value f, or there were f ways of making 1, right? Now I'll check how many what is the frequency of 2, right? So let's say the frequency, or let's just write it as f of 2. Let's say f of 2 is some variable x. Now I'll say I can utilize all of these frequencies of 1, so I can use any of those ones. So let's say I had 3 ones in total, so these are the 3 ones, and now I have 2 twos, right? So I can use any of these twos with any of these ones, right? And there would be 6 combinations in total in this case. That is basically 3 into 2 combinations. So over here it becomes x into f combinations. If x is the frequency, and previously I was having a value f, so it becomes f into x, and now I'll be checking for n is equal to 3. So now my previous would actually be x into f itself, right? Over here also I'll check for the frequency. The frequency could be some other variable a. So I'll say okay, cool enough. I can multiply a with the previous thing. So with the previous value I was having, so it would be f. The value would be, or the result value for three for subsequences and ending with 3 would be x into f into, okay, so it was a, right, which is frequency of 3. Now as soon as you get to a point where the frequency is actually 0, so let's say for a frequency of 4 was actually 0, now you can never make any permutation which has the number 4 or more into it. Now let's because 4 is not present, so you cannot have 4 into in a permutation, right? And because 4 is not present, so you cannot make a permutation of greater size, because if you are having 5 or 6 or any other number in the permutation, you definitely need to have 4 also, so it would get terminated over here. I hope this makes sense. Let me walk you through the code itself. The code is fairly simple. So what I'm doing is I'm taking the frequency array, or you can say an order map. It's a hash map. You can utilize a number of things over here, since m was also limited, so you can utilize a lot of things, right? Okay, then I'm populating the frequency matrix. Then I'm taking 3 variables: result, previous, and last. So what last is doing is that it's calculating what the last value was, right? Okay, okay, give me a second. Let me just walk you through the code itself that is present over here. Okay, cool. I hope I didn't change the code or messed it up. So initially I'm setting my result to 0. That is obvious, right? I'm setting my previous to 1 and my last to 0. Then I'll be going through all the elements possible. So elements from 1 to n are obviously possible, right? Then I'll check that last is equal. Okay, so my last is equal to previous. So what was the previous value I was getting, right? Or in order to make a better nomenclature, I can over here, I can actually change this value to, okay, it can be priv into frequency of I. I can make it like this. Then I can say, okay, previous is equal to previous into frequency of I. In this case, I won't even require this. This looks more neat to me. Let me see. Okay, it failed. What wrong am I doing? Okay, it doesn't have the required test cases. But that's actually the right output I'm getting, I guess. I'll test again. Okay. Anyway, let's test it over here itself. So what I'm doing is firstly I'm populating the result. The result should be equal to result plus the value you should be adding on to the result would be the previous value multiplied by the frequency of the current element, right? And then you'll be updating the previous element itself. So I think this should pass. Let's see. Yeah, but one more thing you'll have to do over here is that since your values can overflow, so just take a mod. Let's try this out. Now the only reason is that even when I was explaining the code, I was trying to modify it, because the code I want you to go away with should be a code that is easy to explain and it's still elegant to look at. Now if I'm using extra variables which are actually not required, it doesn't actually make sense, I guess. So that's the only reason of giving you a code which makes total sense. And moreover, you are able to see that how I code and what are the possible optimizations you can do as well. Yeah, so this is the AC code. Now let's say just to give you more context about it, let's say I skip this particular line, I'm not doing it over here, right? Then we would have actually overflowed the answer, right? If I didn't take a mod over here, we would have overflowed the answer, although we are taking the mod in the result itself. So over here I'm saying result is equal to this is mod this, but even this value matters, right? So if we are not modding it, so we'll overflow it right over here, right? So it's it's required. So here you can see I'm getting two wrong answers. So let's just make it correct and submit it again. So yeah, that's it for the question. Let me know if you have any doubts or any suggestions in the comments below. Cool guys, thanks a lot for watching this video. Bye.